In this video, we will learn types of tables and graphics. First, frequency tables. Frequency tables are tables that list out all possible values of a variable with the following information. Note that not all the following have to be given in the table, but they are all options. First, frequency. Frequency is the number of observations for each values, or we say the counts. Second, proportion. Proportion is the number of observations in each category divided by the total number of observations. Proportion will be a decimal. It is also known as relative frequency. Last, percentage. Percentage is just proportion multiplied by 100, so we are changing the decimal to a percentage. For example, 0.8 could be a proportion. If we want to change the proportion or transfer the proportion to percentage, it should be 80%. Here are common types of graphs for categorical data. First, pie chart. For pie chart, each category is represented by a slice of a pie. The size of the slice corresponds to the percentage of observations in the category. Second, bar graph. For bar graph, there are vertical bars for each category. Height of the bar is the percentage of observations or the frequency of observations found in each category. Please pay attention that for bar graph, bars should not be touching. This is an example that bars are touching, and this is not a bar chart. Later on, we will learn that this graph is called histogram. Histogram is not as same as bar graph. Pareto chart is bar graph in descending order by frequencies. Pareto principle states that a small subset of categories often contain most of the observations. Example 4. Create a frequency table and a graph for this dataset. First, let's count home game. There are 1, 2, 3, 4, 5, 6, 7 home games. That's why the frequency for home game is 7. Then let's count the number of away game. They are 1, 2, 3, 4, 5 away games. So that's why we put 5 here. Total frequency at the bottom is 12. It equals 7 plus 5. The number of a home game plus the number of away game. Then we need to calculate the proportion of home game. The proportion 0.5833 is calculated as 7 divided by 12. Similarly, the proportion for every game will be 5 divided by 12, which equals to this number. You can verify this calculation by yourself. Last, the total proportion will be calculated as 12 divided by 12, which is 1. Last, we need to convert the proportion to percentage, as shown here. Now we have created a frequency table based on this dataset. Based on frequency table we created on last slide, we can either choose to represent this dataset in a pie chart or in a bar chart. Again, I repeat, the graph on the left side is called pie chart. Graph on the right side is called bar chart. Please pay attention that bars in the bar chart are not touching. There are space between each bar. Now we'll study types of graphs for quantitative data. First is dot plot. For dot plot, there is one dot for each observation placed above the value on the number line. We can also use stem and leaf plot to represent quantitative data. Stem and leaf plot displays individual observations. Stem represents all digits but the last one. Leaf represents the last digits of the number. Here are steps to create stem and leaf plot. First, we need to sort data in ascending order. Then we need to place all stems on the left. In this step, we cannot skip any numbers. Step 3. Draw a vertical line to the right of the stems. Last, place all leaves on the right of the vertical line. In this step, each observation must be included. If there are duplicates, then there must be multiple leaves with the same number. We can use histogram to represent quantitative data. Histogram use bars to portray the frequencies or the relative frequencies of the possible outcomes. Here are steps to create histogram. Step 1. Divide the range of data into intervals of equal weights. Second, count the number of observations in each interval, forming a frequency table. Then, construct the horizontal axis and label all values of the intervals. Then construct the vertical axis with all frequency values marked. Last, draw a bar over each interval with the height equal to the frequency found in that interval. Pay attention that side-by-side intervals should have touching bars. Here is an example about dot plot. There are 3 dots on number 5 because number 5 happens 3 times in this dataset. There are 2 dots on number 10 for the same reason. Number 10 appears twice in this dataset. Using the same method, you should be able to draw this dot plot by hand based on this dataset. Example 5. Histogram. This is an example of a histogram. You may have noticed that bars in histogram are touching. The height of each bar is controlled by the frequency. For example, for interval 200 to 249, the frequency of this bar should be 2, which also appears here. For interval 300 to 349, the height should be 4, which equals to the frequency here. The height of each bar is controlled by the frequency in the contingency table. Please make sure that your intervals are equally spaced and there are no overlaps, and every number is represented. Example 6. Create a stem and leaf plot for the variable length of time. Let's create the stem and leaf plot together. Smallest number in this dataset is 3.07. And the largest number is 3.67. We know the leaf is the last digit only, so we know the stems are the first 2 numbers. The first line here represents the smallest number in the dataset. The last line in here represents the largest number in the dataset on the right hand side. Here, the 32, 0 represents 3.20. And this item also represents 3.20. I'll give you another example. Stem 33 and leaf 2 represents number 3.32. Now you should be able to locate every number in the dataset in this stem and leaf plot. There are some information from graphs need extra attention. First, are there peaks in the data? The mode is the most common value in the dataset. A graph is called unimodal if there is only one peak in the data. We call it bimodal if there are two peaks in the data. This graph is an example of a bell-shaped unimodal. This is an example of a bimodal. Later on, I will explain what is bell-shaped. We also need to pay attention to shape of distribution. If the distribution is unimodal, then the data is either symmetric or skewed. This is an example of bell-shaped unimodal. This is an example of a skewed right. This is an example of a skewed left. Because the right tail is longer than the left tail, so we call this one as skewed right. Because the left tail in this plot is longer than the right tail here, we call this distribution skewed left. If the height of each bar is close to each other, looks like this one, then we call this type of distribution as a uniform distributed. If there is a large gap between peak and an isolated bar, then the isolated bar usually represents outlier. In this example, this isolated bar represents outlier. We want to pay attention to spread of histogram. We want to compare width of the histogram. The wider the histogram is, the more spread it is.